Section 4.2, special applications of ratio and proportion applications. Horsepower developed by an engine varies directly as its displacement. How many horsepower will be developed by an engine with a displacement of 220 cubic inches if 380 cubic inches engine of the same kind develops 220 horsepower? Okay, so for every 380 cubic inches, we end up with 220 horsepower. Okay, so they're asking the other one, well, what if you only have 220 cubic inches? Okay, so we have 220 cubic inches. And the question is, what kind of horsepower will that give you? What kind of horsepower will that give you? So that's 380 over 220 is equal to 220 over x. All right, so we're going to cross multiply and then divide. So what we end up with is 380 times x, which will give me 380x. And then we end up with 220 times 220, which is 48,400. And then we undo the multiplication of 380 by x by dividing by 380. And whatever we do to one side, we do to the other. These cancel out, leaving you with x is 127.35842. Well, and it just keeps on going. Okay, so it's repeating. Now, realistically, we probably want to round this to the nearest whole number. And the specific problems within your homework assignments will specify where they want you to round this. So let's say we want to round to the nearest whole number, right? So this is approximately. So let's say we want to round to the nearest whole number, the 7th place right there, okay? Well, to the right of it is a 3. If it's 0, 1, 2, 3, 4, we round down. If it's 5, 6, 7, 8, 9, we round up. So we're going to be rounding down because there's a 3 right there where the arrow is. Okay, so what that means is we just lose the 3 and everything next to it. All that goes away. And we're just left with 127. So this is approximately 127. Okay, so let's try the next one. So if an alternator to engine drive ratio is 2.65 to 1, what RPM will the alternator have when the engine is idling at 300 RPM? Okay, use a direct proportion. Okay, so let's see, we're going to have 2.6521 is equal to, got an x right there, we don't know, but we do know this is 300. Okay, so that gives me x is equal to 2.65 times 300. So we used a direct proportion. Okay, cool. And what that gives me is x is equal to 795. All right, so again, this is, maybe I should have labeled this better. Okay, so this is the alternator, and this is the engine. Okay, and this, they say the engine is idling at 300 RPM. So again, this is the engine. Because I'm sure there might be a question of, well, how do I find out what numbers to put where, right? Okay, so again, alternator with the first number, which was the 2.65. Engine was the second number, which was the 1, alternated to engine. They tell you the engine is 300, put the engine on the bottom with the other engine, and the top one over here is the alternator. Sorry. Okay, and that's how I found out how to set it up. Again, proportions matching. Okay, so let's try the next one. All right, so a city planning commission recently voted to restrict the size of home remodels by limiting the floor area to a lot area to a maximum of 0.3521. Under these guidelines, what would be the a maximum allowable size of a remodel of a 1,170 square foot lot? Okay, so let's say, first of all, we have the 0.35, and that is the area of the floor area. So we have floor area. All right, on the bottom, we have the lot, 2 lot area. Okay, so then we have 1 lot area. Okay, area. My handwriting's really bad today. Okay, so we put the floor area on top. Okay, now under these guidelines, what would the maximum size of a remodel on a 1,170 square foot lot. Okay, so we're going to put the lot down here. And of course, you put square foot lot. And they are asking specifically what is the maximum allows the size of the remodel. So they're actually asking for the floor area. The floor area. Okay, so we finally got it set. Now we're going to do cross multiplication and divide. So 0.35 over 1 is equal to x over 1,170. Okay, so we do cross multiplication. 1 times x is just, well, x, and then you have 0.35 times 1,107, and that gives me x is equal to 4,095. Okay, now what about the next one? Okay, so we still have the 0.35 floor area. And again, I'm over-labeling everything just to try to make it as clear as possible what's happening. And that's over the lot area. And in this case, we have a 3,080 square foot remodel. So that goes in the floor area. And they're saying, what would the lot size be? Well, I say, what size of lot? So this is the one we don't know. And again, this is the lot area. Okay, we just try to make everything match. Area. And this one right here is the floor area. We're just trying to go with the same rules. Okay, and again, you don't have to label everything this thoroughly, but for illustrative purposes, hopefully it makes sense. Okay, and then we put that over the end. So we do cross multiplication, right? So 0.35 times x is 0.335x. And then we have 1 times 3,080. 3,080. And now undo the multiplication of x by 0.35 dividing 0.35. Whatever we do one side, we do to the other. Those cancel out, leaving me x is equal to 8,800. 8,800. So we got that answer right there. And that's the answer to the first part over here. Okay, so the headlights of a car are mounted at a height of 3.5 feet. If the light beam drops 1 inch per 32 feet, how far ahead in the road will the highlights illuminate? First step here is we have this ratio right here, which is 1 inch per 32 feet. Okay, so we have 1 inch per 32 feet. Okay. Now, here's the thing. This right here is the one that has to do with the drop. So if you're 3.5 feet off and it drops 1 inch, okay, the light beam drops 1 inch. This is how high it is to start with. So we need to convert that. This is a little bit different. We need to convert that feet to inches. So this is the question. 3.5 feet equal how many inches? Well, we're going to multiply the 3.5 feet by 12 because you're going to with 12 inches, right? When you're converting a larger unit to a smaller unit, you end up multiplying, generally speaking, and if you're converting a smaller unit to a larger unit, generally speaking, you divide. We'll get into more specifics later on. We will be doing conversions. Okay, so 3.5 times 12 is 42, and that's inches. Okay, so that's the 42 inches. So we're going to put the 42 inches on top, and the question mark is how many feet ahead is this going to illuminate? So we are going to be doing a cross multiplication. So we're going to say x, right, 1 times x, and then we're going to have 32 times 42. And that would give us 1,344 feet. So there we go. Okay. Try the next one. It is known that a cable with a cross-sectional area of 0.2 square inches has a capacity to hold 2,500 pounds. If the capacity of the cable is proportionate to its cross-sectional area, what size cable is needed to hold 7,000 pounds, right? So how do we set that up? Okay. So they give us a ratio right here, which is 0.2 square inches to 2,500 pounds. Okay, so first I'm going to write that one 0.20 square inches. And then over here we have 2,500 pounds. And you can put in more information. You could say of the cable here, and this would be, how much it can hold, whatever. You can more thoroughly label it if you want to. Now, because we already decided we're going to put the pounds on the bottom, I'm going to put the pounds on the bottom there, and then we have an unknown square inch area of the cable here, and that's what we are going to be finding, right? So this is square inches. So we cross multiply, right? So 2,500 times x, which is 2,500, whoops, x, and then we have 0.2 times 7,000, which should give us 1,400. Then we divide both sides by 2,500. Divide by 2,000. Oops, 2,500. 2,500 cancels out 2,500. Those cancel out 0, giving you 0.56 square inches.